So in this section we're going to address the questions of whether or not there is likely to be life elsewhere in the universe, and how we might discover it if it did exist. It's important to distinguish between life, which is a biochemical process, and intelligent life, which is something that we could potentially interact with. As of now, we have found no evidence of life in either form currently exists anywhere. So first let's look at UFOs. Astronomers don't take reports of UFOs seriously. Lights in the sky almost always turn out to be Venus, or weather balloons, or a military rocket launch. There's some also rare, strange atmospheric phenomena that could explain some sightings. The scientist always feels the need to go after the simplest explanation, whereas many people prefer the mystery. You are, however, much more likely to get onto TV if you say you were seduced by an alien than if you saw the lights of a police helicopter. Of course, there's also outright lies, ignorance, and deception, especially by conspiracy theorists. Reports of little green men are not taken seriously by scientists. Why would they behave the way they do? And why do they have 2 eyes, 2 ears, and a mouth? Carl Sagan once said, "Extraordinary claims require extraordinary evidence." So in other words, you have to have very good evidence before anyone will take you seriously. So what's the nature and origin of life? Well, a crucial feature of life is the ability to reproduce itself. The variety of life functions is directly related to the very large number of ways carbon atoms combine together. The information is stored in the DNA molecule, which is a code that was broken in the 1950s. Life on Earth is based on long chains of carbon molecules. So, lots of carbons, maybe nitrogen, hydrogen thrown in there with maybe some other atoms attached to them. The chemistry of carbon, which we call organic chemistry, is much richer than any other element. We have established that elements are the same elsewhere in the universe, so the laws of chemistry will be the same as well. We therefore suspect that life elsewhere will be based on carbon. But we should not discount the possibility that there's some other form of life. Silicon chemistry is very similar and is not out of the question. The important thing about carbon chemistry is that it needs an intermediate temperature range to flourish. Water also helps a great deal. We also need a source of energy to foster chemical reactions. For these reasons, we think that terrestrial planets or moons are the most likely places for life to develop. Well, how did life start? Many people dodge the question and say God did it and leave it at that. However, this only answers the philosophical question of who created the universe, not the scientific question, how did he do it? In general, the scientific approach is to see if we can come up with an explanation that does not require a large adjustment to the laws of nature. As science progresses, more and more of life's processes can be explained by chemical reactions. It is natural then to explore the possibility that life began this way as well. Experiments have been done to simulate the early conditions in the Earth's atmosphere. We're not too certain about the Earth's early conditions, but we believe that the young Earth's surface was hotter because of the increased volcanoes and increased heat from the sun. There was also a lot of lightning and a lot less oxygen. Now, chemistry experiments done by Miller and Urey in the lab used a mixture of methane, water, ammonia, heat, and electrical discharges in a flask for several weeks. After that time, they found a mixture of chemicals, including amino acids, which are the building blocks of proteins. But they did not find a self-replicating system. So this was their experiment. They had a flask of boiling water, and they pumped out all the excess air to begin with. Now, as the steam came up and went into this flask, they had electrodes that had sparks that were going across it. And here we had different gases. The methane, the ammonia, the water, and the hydrogen gas. And then there was some cool water coming in and out. And so as this steam came through here, the cool water would condense it, and it would come out as water droplets. And then as it would come up, it would come back in and eventually go into the boiling water. And there was a trap here that anything heavier than water would get trapped down below. And then they looked at the liquid water in the trap at the end. Now there's disagreement about the significance of these experiments. Some people take the presence of amino acids as a sign that life might have evolved given more time, a billion years or so. Others say it would take an enormous step to get these simple building blocks into a sequence that can reproduce itself. Our present genetic system using DNA is very sophisticated, and we have not yet come up with a scientific theory of how it came into being. Maybe there was an earlier system that came into being more easily, which changed into the present one. If we look at the geological record, we estimate that life began on Earth in the form of very simple organisms about 3 to 4 billion years ago, when the Earth was a lot younger than it was now. Remember, we showed earlier that the Earth formed about 4.6 billion years ago. Early life was very primitive and all in the ocean. Life on land is only about 400 million years old, 1/10 of the Earth's history. Humanoid history may be only 1 to 2 million years old, civilization a few thousand years old. Our ability to think about communicating outside our planet is perhaps 50 years old, rockets and radio. The main point here is that there's been unintelligent life around for a long time, but intelligent life for a very short time. In fact, if you looked at a timeline of the Earth and compared it to a year, the formation of the Earth and origin of life maybe be around March. And we had all these different periods of different life appearing on Earth, life on land only occurring around Thanksgiving, and humans and human civilization only in the last minute or so of the year before the end of the year.